In addition to variation among variables, we often look for covariation among variables. And the co is simply there to indicate that this is saying we're not looking at the values that happen just in one particular category. We're looking at the relationships between variables in various categories. How does one variable change as a result of the other one changing? And sometimes you won't see trends on an individual variable alone, but you'll see trends when you have two variables working together. For example, one place we might see this in the diamond data set is that we may wish to look at the price of a diamond and how many diamonds we have in that particular price point. The first graph on the left does a raw count on how many diamonds do we have at each particular price point and creates separately colored graphs based on the cut of the diamond. The graph on the left is a good introductory visual, but it can hide some trends based on the fact that we didn't have very many fair diamonds in our data set to begin with. So for example, we see fair all the way down here at the bottom. Fair is the worst cut that you can get in our data set, and you see that we don't have very many diamonds in that category at almost any price point. It's difficult to see a trend with what's happening with the fair diamonds. But that might be because we don't actually have very many fair diamonds in our data set at all, where on the contrary, we seem to have lots of ideal diamonds. A way we've seen before to correct for this is to not show raw counts, but to use density plots in order to look at percentages of those categories. And indeed, you'll see that if you use a density plot here for the distribution of diamonds, we can start to make out a much clearer trend in the fair data and an interesting trend in the good data that we may not have noticed from the graph on the left. A new plot that we haven't seen before that can be very helpful for looking at covariation is a tile graph, sometimes called a heat map, but the word that we'll be using in R for this is tile. A heat map can be used when we're comparing two categorical variables, a finite number of options up against a finite number of options. And what we want to know is how many of each combination do we have? So for example, how many I1 clarity diamonds do we have that are fair? How many SI2 clarities do we have with an ideal cut? And we can see those totals over here. And the R code I use to generate this portion of all options is provided right up top here. There's nothing new to be learned in the syntax that we need to create this table. But what's difficult about this table is that we've only shown 10 out of 40 options. And scrolling through all of these options that's 40 rows long can be difficult. So what a heat map does is it plots them in a more rectangular format and color codes the cell at row premium column VS2 with a color that's associated with how many are in that category. So what we lose in looking at a heat map is the exact value of how many premium VS2 diamonds we have. But what we gain is an understanding of that value's relationship to all of the other counts. So very quickly we can see in our heat map over here that we have the most ideal VS2 variables, and finding the least is rather difficult without an exact value, but we can tell that it might be this combination over here, fair IF, or possibly here, ideal I1. The syntax to generate this heat map graph is shown up here. And you'll notice that just about everything is code we've seen before, except the geom object we're using is called tile. And we use the fill attribute to fill in the individual rectangles according to n, where if you'll remember, n is the column header that comes about in the count function for counting the combinations here, unless we indicate otherwise, as we did on the left. Last but not least, I'd like to talk about covariation on two continuous variables when we run into the all too common occurrence that we have far too many observations to plot appropriately in a scatter plot. So that's the image on the left. Two of the variables that we're looking at that are continuous are carat and price. And if we simply plot a point for every observation, it's very difficult to see in this picture truly what's going on. There are a handful of options we can take in this case. One is for us to group things on our own with something like an if-else statement. For example, maybe we want to take every diamond's individual carat and round it to the nearest carat, maybe rounding down or up for ease, to say something like everything under 1 carat, let's classify that as a 1 carat diamond, everything between 1 and 2, let's classify that as a 2 carat diamond, and so on and so forth. And then we can use methods we've used before to create individual box plots for things within that category. So creating our own columns of a data frame where we've grouped things into categories we like and then plotting them individually can help us get a better idea of trends. Or our AES, our aesthetic argument to the box plot function, does have this group argument where you can say to cut the width of the bins in particular increments, and you can accomplish this when you have more than just a couple of things to create on your own to get a better idea of distributions. So this picture over here on the right is taking all of our diamonds, filtering down to just those with a carat between 0 and 2, and then breaking them up into 1/10 carat weight intervals and creating individual box plots on a much bigger scale without having to do that manually. So this is good syntax to know, this group argument, along with cutting the width of a continuous variable. In summary, we've discussed variation and covariation, and the big picture is that variation studies how measurements inside one variable are distributed, while covariation explores how 2 or more variables vary or change in tandem. This is our difference between maybe our box plots and our histograms and our scatter plots. The last summary point, which goes all the way back to the beginning of the videos, is just the general theme of this unit. Whenever we have a brand new data set that we don't know and we don't understand, we need to explore that data to try to find these gold treasures. And only through asking questions, creating visuals, and refining our observations will we truly find what we're looking for.